Hi gang, Rob here. It is the evening of October 2017, and it's finally time for me to make a video about a topic that's been, I don't know, weighing heavy on my mind in the knife world for the last few months. And I didn't want to make this video until I had a solution to what is sort of a problem. In fact, it's, at least from my perspective, a pretty significant problem. The name of the problem is Maxamet. Guys seem to go gaga for Spyderco knives, sprint runs, and exotic steels, and there's been a wave of this with Maxamet over the last year or two. Spyderco did sprint runs in the Native 5 and then in the Manix 2 lightweight, both with gray handles, and now there's one, I believe, in production or maybe hitting stores now for the Paramilitary 2 in Maxamet. And Maxamet, my friends, is a sucker bet. Let's call Maxamet a super steel on steroids. What do we like in the mid-teens of the 21st century? We like lots of carbon. We like lots of vanadium. We like tungsten. Oh, tungsten really turns our crank, doesn't it? And the more of those things we can get in a knife steel that give us unbelievable wear resistance, we think is awesome. Well, let me just read to you from our favorite app. You know the app. Yeah, that one right there. Let's just read to you about Maxamet. What does it say? Let's see. Try to get the glare off. Carpenter Technologies high-speed tool steel uses their trademark micro melt technology. That would be putting marketing spin on that. Micro melt is the old process for powdered metal in Carpenter's realm. The Gen 2 process that they use for CTS 204P and other more current steels is better. Okay, moving on. From production knives manufacturers, Kershaw did try to make a folder out of it, the ZT 888, but it proved too difficult to grind at 60 plus HRC and had bad warping issues if heat treated after grinding. Still, there's hope for Maxamet custom makers. High on cobalt and vanadium, tungsten. 10% may seem like a lot, but in reality it isn't, because tungsten is so heavy. Meaning a lot of tungsten in weight, which is how the percentages are measured, doesn't mean a lot of tungsten in the structure. Okay. So it has high wear resistance, high working hardness, and tons of carbides. Lots of carbides. Will perform better with coarse edge if you get your hands on a knife made out of it. What this text doesn't say is that Maxamet is of extremely low toughness, and that is the problem I have encountered. And in looking at some forum posts, spying on forums because I don't go on forums, I'm not the only one to have this problem. You guys know I sharpen a lot of knives, about 30 a week, using various sharpening devices, media, methods, and this is the 6th Maxamet knife that I have attempted to sharpen, and it's the one I've had the best result with. Let me tell you about the sad progression. Spyderco knives, the Maxamet knives, are probably sharpened at about, well, I know they are. They're sharpened at about 17 degrees per side with a micro bevel of something more than that. And Spyderco, like most manufacturers, when they sharpen at the factory, they're using a belt grinder, which is a compliant substrate, right? There's a little slack in that belt. You don't ever sharpen on the platen. And then they're using a buffing wheel or something like that to polish the very apex. And by the look of a Maxamet edge from Spyderco from the factory, that belt portion of the process is very coarse, like 150 or 180 grit, I'm guessing. And then the micro bevel is fairly polished. Problem is, when you try to sharpen these knives on stones, even if you're replicating the factory angle of about 17 degrees per side, as you come to an apex on your stones, well, something funny happens to the edge. Either you look down and all of a sudden your knife has no tip, or you look down and there's a huge section taken out of the cutting edge, and then you'll find laying on your stone a nice little ribbon of steel that used to be the apex of your edge for, I don't know, a ½ inch or 3/4 of an inch. Now you have a ½ inch or 3/4 of an inch long chip right in your edge. And this is me sharpening, and I have never experienced anything like this with any knife steel. Not one. Not S90V, not S110V, not LMAX, not M390. No super wear resistant, low toughness steel has ever reacted like this. If you guys have ever watched Murray Carter's sharpening videos, you know how he tests his heat treat, right? I'm not going to do it with this knife, but let's grab something, let's grab my beater knife here. He'll take a knife edge and he'll lay that thing down on something hard and press. He'll lay that thing down at like a 45-degree angle and press and bend that edge. And if it chips out, it's too hard. If it deflects and doesn't spring back, it's too soft. If he can bend it visibly and it springs back to straight, his heat treat's on the money. It's kind of a crude way to measure the effectiveness of your heat treat, but I get it. Maxamet, at a normal thickness for a Spyderco knife, normal angle acuteness for a Spyderco knife, with very moderate to light pressure from a sharpening stone, just flakes off in ribbons of cutting edge. The first 2 or 3 knives, well, the first knife that I did, I thought, surely this is a bad heat treat. And then I started reading about Maxamet, and I found out I wasn't the only one to experience this. And some rather well-respected folks in the world of steels and sharpening, Cliff Stamp, I think, for one. I know that I read Cliff on this steel, and I believe he was talking about edges that needed to be between 25 and 30 degrees per side for Maxamet to have enough stability to be used on a knife. I wouldn't disagree with that. I found that I can go a little bit more acute than that, an effective angle, if I convex this steel, because that's sort of shaped like a parabola. It's a decreasing radius on each side as you come to the apex, so the effective angle at the apex is much more obtuse than it is as the knife starts its convex approach to the cutting edge. That worked well. It's not the prettiest thing in the world, but it worked well. This, my 6th Maxamet knife, I took a little different approach with, and I think I found something. This is sharpened at 17 degrees per side, which is just me replicating the Spyderco secondary bevel, but then with a 22 degree micro bevel, and you can see there's a pretty discernible margin or demarcation, if I can get this to work right, between micro bevel and secondary bevel. I think you can pick that up on the camera. Here's what I did. The first thing I did is sharpen the micro bevel at 22 degrees per side. I started with a 600 grit stone, and it was probably polished to 1500 or 2000 from Spyderco. Probably 1500. And it was probably quite convex. So I sharpened at 600 the micro bevel and made it pretty wide. Then went to 1000, still on the micro bevel, 22 degrees per side. Then 2300, and then lowered my angle and just basically refined the scratch pattern on Spyderco's secondary bevel with super light pressure. Again, starting with 600 grit. You can imagine how long it took to take probably a 150 or 180 grit Spyderco factory finish to a near mirror polish, starting with a 600 grit stone. It took a long time. Why do I start with such a high grit? Well, I think of Maxamet as basically a ceramic that looks like steel. 6% vanadium, 10% tungsten, bunch of cobalt, and 2.15% carbon. There's barely any compliant ferrous metal holding all those brittle structures together. Okay? So I think of sharpening this now as I think about glass. Okay? How do we cut glass? Well, we put a big scratch in it with a diamond. A big scratch. Like if I was to start my reprofile with 140 grit diamond stone, I've got a scratch that's very deep, and as I come to my apex, bing, there it goes. So what I wanted to do, my idea was if I start with 600, I'm not going to make any deep, jagged, significant scratches that are going to be fracture points later. So I just sat there forever with 600 and polished this secondary bevel. Remember, my 22 degrees per side apex is already formed, so I'm never getting to a point where it's super weak either. I'm really working behind that 22 degree sharpened apex or micro bevel, just polishing the secondary bevel, and it worked. I got no chipping, didn't have to put a convex edge on it. It looks really nice. Also, one thing you guys will notice, normally when I sharpen a Spyderco knife in a not ridiculous steel like this, you'll notice that I finish the cutting edge all the way to the 90 degree plunge, as evidenced by this paramilitary tip, okay? Or as close as I can with the given radius on that 90 degree plunge. I decided not to do that with Maxamet. I didn't want it to make any sudden changes in direction. And if you notice, unlike most Spyderco knives, the edges on this knife are all very rounded. Even the plunge grind has a pretty significant radius at its start and in its root. Even the spider hole is radiused. I think Spyderco knows that too. On sharp corners exists the highest stress in any steel or steel-like product, and there are no sharp corners. And I didn't want to create one here. So I just sort of rounded over that beginning of Spyderco's factory edge grind as I polished to try to keep everything as gradual as possible. The only thing sharp on this knife is the cutting edge. And I'll be interested to hear from Zach as he uses this how well the edge holds up, because I wouldn't go cutting any zip ties with this knife. I wouldn't be banging it into any wood either. don't know if our push cuts are not at 22 degrees per side, but barely. You can make it do it if you really line it up right. So that's my solution for a bad product, basically. In my opinion, it's really good to have a steel of high wear resistance. But if you're going to, during use or during sharpening, take out huge chunks of the cutting edge, its lack of sharpenability starts to, no, it doesn't start to, it completely outweighs its wear resistance. You know, how long are you going to be there on stones if you have to remove a chip that's 1/2 inch long and 1/16 of an inch deep? Now, you're going to be there a while on this steel, I'm here to tell you. You know, the odd thing is, I have seen Sal Glesser interviewed, you know, like by Nut and Fancy at SHOT Show, talking about steels, and he sort of has laughed at steels of this ilk because he talks about the compromise you have to make between hardness / wear resistance and toughness / sharpenability. And he says you get to a point where hardness and wear resistance are at a ridiculously high state, and what you sacrifice are two other important characteristics: sharpenability and toughness. It does me no good to have a knife edge that will cut cardboard forever before it goes dull, but the moment I cut a zip tie with it and put any sideways stress on the blade, huge chunks come out of my cutting edge. You know, how much of our everyday cutting, especially if we think we bought a super steel that will, you know, perform well and wear well, how much of our cutting, you know, isn't quite perpendicular? How many times do we maybe, you know, do this as we enter material, or we're cutting something that's looped over, that's pulling our edge to one side or the other? Those are all things, those are all scenarios that will expose Maxamet as a very hard, very wear resistant product that's just not well suited to a folding knife. I wish I had taken some pictures over the months of large pieces of cutting edge I've watched disappear, but I haven't. But trust me, guys, do a little research. You'll see that I'm not the only one to have these problems. So here's the solution: extremely light pressure. Start with a high grit, even though you know you're going to be there all day. Form your micro bevel or apex angle first. I suggest 22 degrees or more per side. And then once you've got that completely finished, go back and do your secondary bevel at something probably 17 to 19 degrees per side. That should alleviate your chipping problem. Some folks surmise that maybe in the forums and threads I've read, surmised that there was a batch of Maxamet that had a bad heat treat from Spyderco. I'm thinking not, because the problems I've experienced have been without fail on 2 different models over a lot of time. So maybe it is bad heat treat, but it seems that Spyderco does that bad heat treat all the time on their production sprint run knives. So if you're going to buy Maxamet, be under no illusions. It is not indestructible. There is a trade-off when it comes to knife steel, and Maxamet is way to one end of the spectrum. I've told guys that have asked me about Maxamet Spyderco sprint runs, and I stand by this, even though I had success with this knife. It's not geometry I would ever use on this knife, except for the steel, by the way. Too obtuse. My opinion is, it is probably the worst knife steel I've ever worked with. That's my 2 cents. Your mileage may vary. In fact, most of the guys who buy these sprint runs in Maxamet are probably never going to cut anything and never going to sharpen them. And some of those guys will go on forums because they know they spent a whole bunch of money on the Emperor with no clothes steel, and they're going to tell people how they've had no problems with it. So beware, my friends, beware. That's all for this one. Grace to you and peace, my friends, from God our Father and the Lord Jesus Christ. And remember, the Word and Zach's Maxamet and Mannix are sharp.